In finance, the Sharpe ratio is a ratio that measures the reward to risk of a portfolio. So here's the formula that you can use to calculate the Sharpe ratio of a portfolio. We take the expected portfolio return minus the risk-free rate of return. So for the risk-free rate of return, that would be something like a 3-month US Treasury bill. So it's an investment that has zero risk associated with it. And then we're dividing that by the standard deviation of the portfolio return. So really, all the Sharpe ratio is doing is it's telling you the ratio between the expected reward of the portfolio divided by the risk or the volatility, which is measured by the standard deviation of the portfolio return. Let's check out an example of how to calculate it. This says calculate the Sharpe ratio for a portfolio with the following data. The expected portfolio return is 10%, the risk-free rate of return is 4%, and the standard deviation of the portfolio return is 3%. So the Sharpe ratio, to calculate that, it's pretty straightforward. We just take the expected portfolio return, which is 10%, or as a decimal, 0.10. We subtract the risk-free rate of return, so 4%, as a decimal, that's 0.04, and we divide that by the standard deviation of the portfolio return, which is 3%, so 0.03. So in the numerator, we end up with 0.06 divided by 0.03, this turns out to be 2. So the Sharpe ratio for this portfolio is 2. Now, where the Sharpe ratio really shines as a ratio is when you can use it to compare different portfolios. So as an example, let's say we have two portfolios, portfolio A and B. Portfolio A has this data, which is actually the same data that we just used. So the Sharpe ratio we found was 2 for this portfolio. But now consider portfolio B. It has the exact same expected portfolio return, has the exact same risk-free rate of return, but the standard deviation of this portfolio is 6%, which notice this is double the standard deviation of the first portfolio. So when we go to calculate the Sharpe ratio for portfolio B, the numerator is the same. This is still 0.06. But then when we divide by the standard deviation, we're dividing by 0.06. So the Sharpe ratio turns out to be 1. So what this is saying is that the Sharpe ratio for portfolio A is twice as high as the Sharpe ratio for portfolio B. And this makes sense because in portfolio A, we're getting the exact same reward, but we're only taking half the risk. So the standard deviation or the volatility of portfolio A is half as much as portfolio B, so it has a higher Sharpe ratio. In other words, we're getting the same reward for less risk, so we have a better Sharpe ratio. So when we're comparing portfolio A and B, we would prefer portfolio A because we're getting the same reward, but we're taking less risk. So our reward to risk ratio is better.